Hello, everyone. My name is Eugene Park, and I'm an associate professor of graphic design at the University of Minnesota, Twin Cities. Today, I'd like to share a project about visualizing a series of dialogues between various design professors and practitioners from Minneapolis that were held over Zoom since early 2021. While there were a lot of insights that were learned during these sessions, but we thought perhaps more could be learned if we could transform the archive of Zoom transcripts into a visualization that provided a different perspective about these discussions. One of the inspirations behind this project was Notabilia, which was a visualization created by Moritz Stefaner and his collaborators. This work visualizes various discussion threads on Wikipedia, where each line represented a specific wiki article that was nominated for deletion. The direction and color for each line segment represents the different arguments that users submitted that were either in favor or in opposition for deleting the article. Another insightful perspective for this project came from Lorraine Daston, a science historian from the Max Planck Institute for the History of Science, and wrote that the archiving for the sciences requires a collective undertaking and later calls the need for a cultural will for their preservation and accessibility. Even as we live in an age surrounded by buzzwords like big data and automation, scholars like Daston point out that no matter how far technology has advanced, one cannot truly renounce the requirement of human labor from any archival project yet, whether we're talking about manual entries to writing code to replace those tasks. Any work involving large amounts of data is still a community-driven effort. The collective effort required for this project called for the involvement of 2 research assistants and students from a class that I was teaching. The process began with one of the research assistants writing a Python script that took the raw transcript file from Zoom and cleaned it into a more usable format. The next step was enriching the data, specifically adding fields such as the speaker's affiliation, as well as a keyword that encapsulates the topic of what that speaker said. The assignment of keywords was carried out by students enrolled in my class who watched the video recording and read through the transcript and discussed amongst each other what the appropriate keyword would be for each statement. Once a consensus was reached on the keywords during class, they would be added onto the data set. The intention behind this stage was to provide students with a challenge to learn from what was discussed amongst design faculty and professionals and put forward what they gathered from their discussions. After the data set was finalized, I, with the help of another research assistant, proceeded to visualize it as an animated timeline, where each rectangle here represents a statement from a unique individual. The horizontal position of each block corresponds to the time in which the statement was delivered, while its vertical position is lined up with the keyword associated with its contents. Altogether, the visualization is meant to show how a narrative of how these discussions evolved over time. In some of the graphical outcomes, one can see not only how the conversation topic shifted and changed over time, but also how other participants related to the topic being discussed. In this session, where the main topic was about designing medical devices and environments, it was interesting to see how the dialogue started on topic, but then shifted towards teaching interdisciplinary and multidisciplinary design. Considering how most of the Zoom session participants were design faculty who didn't specialize in this area, it made sense how they would discuss ways on how to apply or respond to the topic towards a classroom setting. We also had the opportunity to explore different machine learning approaches to automate the keyword assignment step, specifically with AWS and the T5 natural language processing model, the latter of which the process is shown on the screen. However, there were several limitations with these approaches. The first of which was the model's heavy reliance on word frequency to determine the keywords, which often yielded unreliable results, the specific of which is on the caption here. The second issue is that these pre-trained machine learning models weren't intended for analyzing technical topics such as design, which also kind of explains that previous issue. So the question of whether topic modeling and natural language processing methods eventually become suitable for analyzing design-related discussion topics still remains to be seen. Regardless, there is still value for designers still employing manual data aggregation and enrichment for the purposes of research and teaching. Similar to how design educators often encourage students to sketch and prototype using analog techniques, manual annotations aided with modest and intentional automation and tools can teach designers and students on the discipline and patience behind the process. Whether we're talking about machine or human, we are all still learning together. So the next steps for this project is to transform the animated visualization into an interactive experience, the rough prototype of which is shown on this slide. So we hope to have more to show about this particular direction in the future, but until then, I look forward to receiving any feedback. So thank you for watching.